Ladies and gentlemen, welcome to week 6 of our online course, Business Process and Decision Modeling. And this week 6 is about business decision modeling. So this is where finally BPM meets DMN. Week 6 is organized as follows. In the first video clip, I like to motivate the topic. The second video clip provides an overview of the DMN, the decision model and notation. In video clip 6.3, we look at decision requirements diagrams, while 6.4 introduces decision logic. In video clip 6.5, we introduce the semantics of decision table, and 6.6 looks at the analysis of decision tables. In video clip 6.7, we investigate the consistency between process models and decision models. Okay, so let's start the motivation. So if we look at business processes, and we have these seen in the last weeks, many business processes actually contain decisions. And there are actually two types of decisions. One type of decision might impact the sequence flow, and these are often activities that precede XOR gateways. But there are also decisions that assign values. So, for instance, I decide on the discount for a specific customer. An example of the first kind we have seen here, and we have this seen earlier in the introduction already, where we have a process that decides on whether a credit card application can be granted or not. And here we have, first of all, the start event when I receive the credit card application. First, you need to record the application information, and then we have the decision task. And this decision task called determine basic credit card eligibility, and it has two outcomes. So the decision has two outcomes, and this outcome of the decision are used to control the flow of the process. So either it's yes, then I'll determine the final credit card eligibility, and if it's no, I will send an application rejection. Yeah, and here we have another decision, and if it's yes, I go that way and I finally accept the application, and if that decision is evaluated to no, then I also end up in rejecting the application. These decisions are very important, and many people say that it's the decisions that make or break your company, and therefore it's really worth into looking at exactly how these decisions are taken, who is responsible for taking these decisions, what are the inputs of the decisions, and what is the structure of the decisions. There's also motivation related to process automation. So we have talked about process automation already, and we have seen this architectural diagram that you see here in the lower part of this slide. What actually happens here is that when you look at the execution of this determine basic credit card eligibility, what happens is that the process engine maintains the process instance. And what it does, it calls a service provider, and so what is the, please decide for me, should I accept the credit card application or not, and then I get a return value back, and then I use that to control the flow. If you look at concrete implementations, then we often have the case that the decision is actually implemented in software. So it looks basically like that. So when the process is at the point where it needs to determine the basic credit card eligibility, some service is invoked, some piece of software is invoked with the data of the customer, and it is returned either yes or no. So shall I or shall I not accept the application? But this also has a number of drawbacks. And these are the following ones. So we don't know how the decision is actually taken. We know that it's taken by a piece of software, but we don't know how the decision is taken within that piece of software. It's also not exactly clear which data is being used and which policies are taken into account. And we also are not quite sure of who is actually responsible for taking the decision. So the decision is coded in software and it's not explicit in models. And we like to change that. We like to make decisions more accessible through models. But it's also often the case that a decision is taken by a process participant. And in this case, the logic is, let's say, outsourced to the person, and the process participants, decide whether I should accept or whether I should not accept the application. So to put it a bit bold, it looks like this. So either I do yes or no. Actually, I have very similar issues than in the first situation. So it's also not exactly clear how the decision is taken, and also which data is being used by the process participant. It's not exactly clear. Also, which policies are taken into account. What we know is that who is responsible for the person. So we know that, but we just know who is responsible. But we could look a bit more, a little deeper into the organizational aspects, as we'll see a bit later. In our work on decision modeling and decision management, we empirically looked at more than 500 process models from the financial industry. And we found a very interesting situation here. So we found examples where the decision logic is actually encoded in the process. I brought you one example here, and that is about determining the debt and determining employment history to come up with a credit rating. Credit ratings can be either A or B or C. And the employment history and the debt is used for taking that decision. So first we determine the employment history, then we determine the debt of the applicant. In this process model, we first look at the history. If it's a good history, we check the debt. If it's a low debt, we set the credit rating to A. However, if the debt is high, we set it to B. But we set it also to B if the history is bad and the debt is low. And finally, we set the credit rating to C if the debt is high and the history is bad. So we end up here with ABC. We also found variation of this. So as I indicated before, the process models are being misused sometimes to model decisions. We also saw a different version of that. And here we have the same decision logic encoded in a different process. So here first the debt is evaluated. So when the debt is low and the history is good, I go to A. When the debt is high and the history is good, I go to B, and so forth. So basically the same decision logic is encoded here, but in a different process model. So what we see here that the process constrains execution, the execution sequence of activities, while not providing the actual decision logic. And that's due to the fact that the sequence flow does not reflect the causality. So we learned that sequence flow reflects causality between activities in the process, but this is not the case. For instance, if you look at the first two activities, determine debt and determine employment history, they could also be executed in the other way around because there's no causality between those two. And that shows, I guess, quite nicely that we should not misuse process models to model decision logic. All right, that brings us to decision management. So decision management, the idea of decision management is to describe decisions in a dedicated decision model. We focus on well-defined operational decisions like granting a credit or like processing an insurance claim. The focus is not on strategic decisions like entering a new market. These are too complex and there are too many inputs to go in this, and this information cannot be well represented or concretely represented in decision models. The focus is rather on operational decisions. The modeling goals that we aim at are improving transparency, maintainability, and change. And we also want to support the automation of repeatable operational decisions. We do that by explicit representation of the decision structure and the decision logic to provide also a common language for domain experts and engineers. This brings me to the end of video clip 6.1, in which we motivated decision management. We wanted to avoid undocumented decisions in processes, and we also wanted to avoid representing decisions in process models. We want to answer questions like, how is the decision actually taken? Which data is being used to take the decision? Which policies are taken into account when taking the decision, and also we want to make sure we know who is responsible for taking a decision. And finally, we want to provide a common language for domain experts and engineers.